Okay, this is Algebra 2, also college algebra, and we're looking at section 1.1. All right, so the first thing we need to do is identify function families. And you guys may remember this from your time in Algebra 1, so hopefully this whole first chapter is going to be a bit of a review for you because it's all stuff that most of it you've seen before. All right, so the main function families that we're going to be talking about in this section, a constant function has a constant value, constant y value. In this case, the parent function is f of x equals 1. Linear function, notice that it goes through the origin, and the parent function for that is f of x equals x. These v-shaped graphs are absolute value graphs, and the parent function for absolute value is f of x equals the absolute value of x. And then I forgot to draw in the quadratic, as we know, is a parabola. And the parent function for a quadratic is f of x equals x squared. Notice that all of these parent functions, other than the constant, goes through the origin. Okay, when we talk about transforming functions, a transformation changes the size, shape, position, or orientation of a graph. What does that mean, orientation? Well, it means, does it point up, does it point down? Like these two, the orientation on these both are pointing up. The opposite orientation would be that they're pointing down. A translation is a transformation that shifts a graph horizontally or vertically, but doesn't change its shape or its orientation. And we call that a rigid transformation because the shape of the graph doesn't change. Okay, we're going to do some work with the graphing calculator just to show you how some of these things work. We'll see if this works. You guys can see my graphing calculator. Oh, that's terrible. Give me a second. The glare is terrible. Okay, well that's not going to work because you can't see my screen on my graphing calculator. So you guys are going to grab your own graphing calculators or open up in a new tab a graphing calculator utility like Desmos is a good one. You can go ahead and pause this video while you get your graphing calculator or something online ready to go. And then come back and we're going to, if you're using your graphing calculator, this is going to be on the first line that you do. You're going to graph f of x equals x squared. So that'll be your first graph. On your second graph, I want you to do f of x equals x squared plus 2. And let's talk about what happens after you do x squared plus 2. So you'll notice that when we make this change to our parent function, this shifts the graph up 2 units. So then when you graph this one, you'll see that this shifts the graph down 2 units. Okay, so now I want you to clear these two. Keep number 1 up there because that's the parent function and we're comparing everything that happens to the parent function with these changes. And now I want you to graph f of x equals x plus 2 in parentheses quantity squared. And when you do that, you will see that this shifts the parabola to the left 2 units. And then graph this one. And when you do that, you'll see that this shifts the parabola to the right 2 units. So if we're adding a constant to the outside of the x term, it's going to shift your parabola or your graph up or down. That's a vertical change. If we do it, if we make that change, add or subtract a constant to the x term before we do anything else to it, that's a horizontal shift. And for right now, until we get into more specifics, just keep in mind that if it's a horizontal shift, it's the opposite of what it seems like it should be. So if this is +2 inside parentheses, it's a shift to the left. If it's a minus something, it's going to be a shift to the right. So now I want you to delete those two. Keep this one as your number one function. Again, we want the parent function up there. And now I want you to graph f of x equals 2 times x squared. When you do that, you'll see that that parabola got real skinny. Like it was stretching towards away from the x-axis, right? Let's see this thing here. So now, when you graph f of x equals 1/2 x squared, or 0.5 x squared, you will see that that parabola got real fat. We're going to talk about this. I'm just going to tell you right now. We'll talk about it later with notes, but right now, this is called a vertical stretch. This is called a vertical shrink. This is stretching away from the x-axis. This one is shrinking towards the x-axis. All right, so now, I guess we're going to talk about that right now. I forgot that was next. Okay, so when the factor multiplied to the output is greater than 1, you're going to get a vertical stretch. So that's like when the parabola got real skinny. When the factor multiplied to the output is greater than 0 but less than 1, the transformation is a vertical shrink, shrinking towards the x-axis. Note that in both of those cases, the x-intercept did not change. The x-intercept stayed the same. In the case that we just did, the x-intercept was 0, right? That's it for 1.1. Thanks for joining me.